All right, good day again, everyone. Welcome back to KodeCamp DevOps Bootcamp. Today, we are going to be talking about infrastructure as a code, and we will be building up on the lessons we've had on cloud engineering with AWS. So we'll be talking about infrastructure as code, what it is, how to work on it, and we'll be talking about a special tool today that helps us to create an infrastructure, our infrastructure, using code. So, so very quickly, um, our contents will be starting from the basic concepts of infrastructure as code. Then we'll go on to creating resources, um, then creating and working with modules, which help us to um, have to make our code more readable and more functional. Then looking at logic in Terraform, and then we'll have some review questions, and then we'll, if we have the time, we'll go into some hands-on. So introduction to Terraform. Introduction to infrastructure as code with Terraform. So first of all, what's infrastructure as code, right? When we talk of infrastructure as code, it is a practice that allows us to create infrastructure resources. That includes compute resources, storage resources, database resources, networks, and cloud resources or physical resources, infrastructure resources that our code can be built upon. And we can create these resources using declarative programming languages or declarative scripting languages that can be saved, that can be version controlled like normal application code. So if we're able to create resources from code, there are various advantages that we can get with things like that. Like we can now have our code or our infrastructure in a place where it can be seen and reviewed. Like since it's not imperatively created through using the console or manually, anybody can come and look at the code and know how and what has been configured and deployed within our infrastructure environments. That is a major advantage and a major reason why most organizations, especially when you're working at scale, and even smaller organizations and teams, prefer to create resources and create and build out their infrastructure using infrastructure as a code. So, and there are many infrastructure as code tools that are in the industry today, depending on what you want to work with. There are some that are proprietary to different cloud platforms, like the infrastructure as code tool in the AWS environment. It's CloudFormation, the one in Azure, it's Azure Resource Manager. There are also some cloud agnostic ones like Pulumi, which works with various programming languages as software development kits. And finally, there is Terraform, which is a very popularly used infrastructure as code tool. So Terraform allows you to define your infrastructure using a high-level syntax. So it's created by HashiCorp, the organization called HashiCorp, and the language that's Terraform uses is called HCL, which is HashiCorp's configuration language. And you use the HashiCorp configuration language to build out Terraform resources for various use cases and tools, including cloud providers, Kubernetes environments, Ansible environments, and various other tools. Most things in infrastructure have a provider that you can work with for Terraform. So it says here that the configuration can be versioned and treated as you would to other code. This is talking about application code. And the infrastructure, Terraform can manage low-level components and such as your compute instances, your storage instances like we spoke about, your networking instances, so also high-level components like DNS entries and SAS features. Like if you want to work with configure a SaaS product, for instance, you can also work with Terraform for that. So some major components and major features of Terraform that you use in building out a Terraform configuration script include your providers, which basically specifies the kind of resources that you want to create. So your provider can be your cloud provider like AWS or Azure or Google Cloud, or you can also create a provider for something like maybe an API to like maybe Kubernetes. You can work with a Kubernetes provider. You can also have various tools, expose APIs that can be used as providers within Terraform. Also, there are resources, depending on the provider that you work with, there are resources that Terraform uses to create various resources and various components within your provider. So resources are like the most important elements in your Terraform language. Each resource block, right, describes an infrastructural object that you want to create, and you can now go down into the specifications and the configurations for those components, which could include your compute instance, your storage, your database, your networks, and any components you want to work with. And to take it a step further, to take it a step ahead of just working with resources, you can create reusable configurations for various resources and package them into what we call modules. So a module can contain a single resource or multiple resources that can be packaged together and can be called multiple times or at any time within your Terraform configuration file, right? Modules are like work on the same idea as you have as functions or modules in programming languages, where you configure a body of resources or a body of executable logic that can be used at various points within your code, right? So this is the basic file structure for a Terraform configuration, a Terraform resource or deployment would look like this. You have your main file, right? Terraform configuration has the file extension of .tf. So you can have your main file, which is the main configuration file where you have the bulk of your resources, or where you call your modules, as the case may be. Then you have your variables file where you can now input your variables and separate them from your main file. So these variable files, the variables you input in your variable files can be called within your main TF file and used there. Now the output file, when you create a resource, there are some outputs that it can give to you, for instance, after it has been created. For instance, if you create a VPC within AWS, for instance, now, after the VPC is created, AWS assigns a VPC ID to the VPC you've created. So you can create some KodeCamp. You can create KodeCamp VPC, for instance, and then AWS goes ahead and assigns a VPC ID to you, which could be VPC-ID, some random alphanumeric string for you. That VPC ID can only be gotten after the VPC has been created, right? Just like your instance ID and all of that. So you need a way if you need a way to get that ID, right, or for Terraform to output that ID so that you can use it in another part of Terraform, right? So you can specify that within your output file, right? Okay. So you have your main, these are the major important ones, your main TF file, your variables.tf file, and your outputs.tf file. There are also other files you can create, like your tf-vars file, where you can put in the default values for your variables, but that is an optional provision. You can also create various files as your use case might need. and just attach the extension .tf so that Terraform can know that you want to work, it should use that file, go through that file and create resources as specified within that file, right? So you can have maybe your ec2.tf if you want to specify a lot of ec2s within one ec2 file, or your entire ec2 configuration within a separate file. You can have that. You can have s3.tf or something like that. Or you can just decide to specify all of that within your main.tf file. Depends on how you want to structure your application files and your application codes. Right? Okay. So your Terraform file, a quick example can look like this. You specify your provider, of course, because Terraform has many providers, and for it to know the particular provider that it should work with, you would have to specify a provider. Your provider can be AWS, your provider can be Azure, your provider can be GCP, it can be Kubernetes, it can be there are various providers that you can work with, and we will look at some of them in the coming parts of this video, of this lecture. So watch out for that. So you have your provider here, where you specify it, you pass some parameters to your provider. You can pass the region, you can pass some other variables within your provider. Then you specify your resource. Here we are specifying a resource as AWS instance, which would create an EC2 server or an EC2 instance within AWS. And we give the resource a name within our configuration file, which here we put as example. We can also go ahead now to create the resource by setting required or optional resource parameters, resource specifications within the resource. Like here, we have specified the instance type we want, which is T2 micro, which is usually a free tier instance. And then we've specified the AMI that creates that's Amazon machine image that should create this resource out of. Next up, we specify our variables. You see that in the providers, the region, we specified it as var.region, which is telling this the Terraform that there is a variable specified in the variables.cf file called region, and it should take the value of that region and input it here. So in our variables file, we've gone ahead to specify the region here, which is our default, has set the value with the default attributes to EU West 1. And then in our output, we are outputting the ID of the instance and setting the value to aws.example, which is AWS instance, which is our resource, AWS instance.example, the name we gave to the instance, and the ID. So this is what a basic Terraform file structure looks like. So Terraform, when you execute Terraform within this directory, Terraform compiles these files and uses them to create a resource within AWS, an EC2 resource, an EC2 instance within AWS in the region that we specified. Okay. So a very important aspect of working with Terraform is managing your Terraform states. Your Terraform state, your infrastructure states, which is the present configuration of your infrastructure. What your infrastructure looks like at a given point in time is what we know as the state of your infrastructure. And Terraform attempts to track the state of your infrastructure using state files. So when you create a resource, the configuration is saved within a state file. So Terraform uses state files to keep track of your infrastructure. The state file is a critical component for Terraform to map real-world resources to your configuration and keep track of the various metadata, various configurations, the various logic that has been used to create this infrastructure, and then can use that to build on that, or to take out, so that it can know what your infrastructure looks like at every given point in time, right? So to specify the states, right, of this, where Terraform creates the state file, you use the backend configuration, and by default Terraform saves your state file locally, right? That poses an issue when you are working with a distributed team. How do I mean? Okay, if I create a Terraform file and Terraform creates a state file of which contains all the things that I've created using my Terraform, and all the things that are presently in my infrastructure, right? And Terraform saves that into my local environment, and every other developer has the state file saved in their local environment. What's going to happen is that each user's Terraform, each engineer's Terraform could be seeing a different state of the Terraform file. So the best practice is to create a central state file that every developer can work with. So my Terraform can read the states of the infrastructure from the same state file that the next developer is reading from. So everybody's Terraform agents is seeing the same states of the infrastructure. So if I make an update and it saves the object I made, so that's remote state file that everybody's seeing, everybody can see the change that I made, or the updates that I made, or the modification that I made to the infrastructure, and everybody can work with that. So it's a good practice to have your state file stored or kept remotely, and have all your developers have access to that. This is the best practice. This is the best practice for production environments and production use. This is the best practice when you're working with a distributed team. Having a local state file should be for your tests, your local tests, and probably for learning purposes as well, right? So we see here that how we can specify the backend, where the state file will be located or will be sent to. So you can create an object storage location depending on your cloud provider. Here in AWS, our object storage is S3. We have a different object storage in Azure. Please, if you know what that object storage is called, drop it in the chat so that I'll know that I have some very excellent engineers here with me, and I have a distributed cloud agnostic team that I'm working with, right? So you can specify your backend for AWS as S3, create a bucket, and create the path, the key to your file, your state file, and maybe specify the region if necessary, as the case may be. Okay. So some important Terraform commands as we work with. Does anybody know the object storage of Azure really quickly? Drop it in the chat, okay? We have somebody. Benedict says Azure Blob Storage, and thank you very much. That's really very correct. Azure Blob Storage. So you can also set that as your storage location, your backend location, storage location for your state file if you're working with Azure. Okay, so some Terraform commands that you would come across with your working Terraform. The first one is Terraform init, right? This is used to initialize a directory as a Terraform directory, so that Terraform can manage the files within that directory as Terraform files, and creates resources, creates infrastructural resources from the files that are within that directory. So if you create a directory and you create your main.tf file, you create your vars.tf file, you create your output.tf file, and then you do your you try to do your Terraform apply, for instance, to apply that configuration. It won't work if Terraform is not initialized within that directory, right? So it works the same way Git works, for instance, for that aspect. So a directory needs to be initialized as a Terraform directory using Terraform init. The next is Terraform plan. Terraform plan shows you, after you write your configurations, you create your configuration using your Terraform files. Terraform plan does a dry run of those configurations and shows you the changes that configuration will make to your present environment. Already, you know that this will work with the it will look at the Terraform state file and look at things that you've configured and tell you what's the changes you'll be making to the present structure would be. For instance, if you're creating an EC2 instance, for instance, it will show you that this Terraform configuration that you've done is going to create an EC2 instance. If you're changing the name of your EC2 instance, for instance, show you that it's going to modify EC2 instance, and this way is going to be changed. If you're deleting an EC2 instance, it will show that it's all the things that you're creating, it will show you all of that. That's what the Terraform plan does. And it's a good practice to always do a Terraform plan before you do your Terraform apply, which executes the changes that you've made into your environment, right? So Terraform apply is the configurations we've done and executes them, actually does the creation of these resources within your specified provider. Terraform destroy now is everything that you've done within the Terraform directory that you're working in, right? If you've made any changes or created any new files within that directory, it takes that and it destroys it, right? So when we usually work with the previous classes we did on AWS, so that we created some things and then we had to go back one by one to delete them to clean up the cleanup we're talking about. So that's because we know we just created this for test and proof of concept purposes, and we don't want to keep them running, right? So we needed to clean them up so that we don't pay for something we don't need. With Terraform destroy, you can just use one command to delete all of that. It also provides you a means to specify the particular directory that you want to delete from, so that you don't take down your entire infrastructure because you want to make one change. Terraform destroy also runs a bit of Terraform plan before it destroys and asks you if do you really want to delete. It does all of that. So, but it is the best practice to specify the particular directory that you want to destroy. Just to be safe, it's the best practice. Okay, that brings us to best practices. So best practices while working with infrastructure as code. The first is to work with version control. So you've gotten your infrastructure into a codified format where you can declaratively create your resources. So if you're managing it like application code, you should also work with version control the same way you will in normal application code. So you can use Git to track the history and the changes of your infrastructure code over time. You should also modularize your code using modules to organize your code and make your code reusable in order not to repeat yourself, right? That's software engineering methodology, so not repeat yourself. Modularize your infrastructure code. Also, you should use remote state files like we spoke about earlier. Your state files should not, especially when you're working with a distributed team or in a production environment, your state files should not be local. You should also always create a remote location for your state files for better collaboration and better security. And then you should also lock your state files to prevent concurrent operations from, to avoid corruption of your state files. Environment management, this speaks about using workspaces or separate state files for different environments. If you're working with development environments, staging environments, and production environments, it's a good practice to have various state files for each of them. A tool that can help you with this is TerraGrunt, which is outside the scope of this class, but it's something you can check out on your own if you're up for it. TerraGrunt, don't forget that name. So part 2, we just finished part 1, which is our basic talk about Terraform. Part 2, we're going to look into the advanced Terraform usage. Now, this is where we will talk about the beauty of modularization in your infrastructure. So, I hope we can all see this. So, creating a Terraform file. These are just some ways to create Terraform files that we can use. Just as an example. So the basic file structure for working with modules. So a module you can create a module with the same standard files that you use within your main Terraform directory, which is actually called your root module. So you can now create child modules that could be later called in your root module. Say, for example, we have a module, I name that my EC2 module, and then I specify the various configurations that I want to use for creating EC2s within my team, within my organization, within my Terraform infrastructure and my environment. I can also have another module for another resource, maybe my databases. I can have another module for my VPC. I can have another module for maybe my storage locations. I can have another module for my volumes, EBS, EFS. And then I can call these modules within my main Terraform environment to create these resources. Now, when I do this, I'll see that I can now say, okay, I want to, within my roots module now, that's the main Terraform in the directory, I can now use the same module, the same configuration for EC2 to create various servers, right? I can use the same module and the same configurations to create various VPCs without having to rewrite the same sets of code. I can just call them. Call the child module within the root module and create these things for me, right? Okay. So let's take a look at modules. So in Terraform, modules are a way to organize and reuse configurations. They allow you to group resources and variables together into a reusable unit. So it's a unit that you can call anywhere and use anywhere. The root module, every Terraform configuration, every Terraform directory you create a Terraform directory, you specify your main TF, variables TF, your outputs TF. You have just created a root module, right? So every Terraform configuration has at least one module, which is known as a root module, which consists of the resources defined in the Terraform TF files and in the main working directory. Now, beyond that, you can now have child modules that you create locally, right? Terraform lets you create child modules, which you can now call within Terraform. You can now call within your parent modules. You can now call within your root modules and use them. And you can call them as many times as you want, as many times as you need within your root module. The next one is your published modules, right? So various organizations can publish modules either publicly or privately. You can have them published, and then you can call those modules. For instance, you have AWS Terraform repository on GitHub right now where you can go and use the modules created there to create you can call them within your local code and use them to create resources as specified by AWS themselves. That's really interesting if you think about it. So basic structure of modules, just the same way we have within our root module, you create them with your child module as well. Now this is a basic use of modules right here. We have someone calling a module from the source, and he's calling it from Terraform AWS modules, which is the public Terraform modules it's published by AWS, and it's calling VPC and it's calling AWS VPC. You can take a little deviation and look at that, what that looks like. So we have Terraform AWS modules right here. Yeah. So you see, this is a collection of Terraform AWS supported modules by the community. And if you come to this VPC in here, I'm sure there should be a README file. Okay, so it shows you how to use it right here. Let us look for the GitHub page of this. Source inputs. Okay. Okay, so this is the GitHub page. Yeah. So in here we have Terraform modules, and we have various modules that we can work with and various repositories, right? Okay. So back to our class. So now let's quickly look at logic in Terraform. Logic. So Terraform provides you a mechanism to incorporate logic within your code to create dynamic code. When you speak of logic, you think of methods used in programming to have the computer create and do work on its own. We're talking about things like decision making using if else. You have things like looping, conditional logic, and things like that. So you can create dynamic configurations, tailor resources based on various values or conditions. You can reduce code duplication using logic, using loops and repetitive resource creation. You can also enable flexibility. So the first one is conditional expressions. The syntax basically is you specify a condition and you set the true value and the false value. You can see a use case here where create buckets is set to false, right? And then you have the creation of the resource. and the count of the variable creates buckets and the bucket creation, right? So you have to, it evaluates the condition whether it's true or false and perform an action based on the results that it gets. We also have looping. Looping is done using the for each function of the count function. So that these are some examples of how they are used. So you see that we've set the default to T2 micro and T2 small. And we are now saying within AWS that for each variable within instance, for each of the variable instances, we are to create an instance type. And for to create an AWS instance using the AMI there, and the instance type will be the value of what is being looped in there. So if you understand looping in programming, this for each will be very familiar to you. The count also, you can set a number. This will be what you understand better if you work with while loops and do while loops within programming. So you can have this, you set a value and then it creates as long as that value remains true, right? So that will bring us to the end of this lecture. That was a very quick one. I hope we all understood what was spoken about. And to evaluate that, I have some quick questions here. Please raise up your hand before you answer any of the questions. We're going to start from the first one. What exactly, in your own understanding, is infrastructure as code? I'll begin the first person to raise their hand. Question one, what is infrastructure as code? All right, Michael, what go everybody? Michael, go ahead. What is infrastructure as code?
Uh, to my own understanding, infrastructure as code is practically it's more like using scripting languages to create resources on the cloud. So basically creating resources with code.
Using code to create resources. That's very correct. Can I have another person? All right. Ujunwa Princess, what is infrastructure as code?
Good evening. In my own understanding, I think infrastructure as code is a way of describing infrastructure in a textual format, which is usually code that is executable.
That also is very correct. Declaratively describing your code, your infrastructure using code. Thank you. One last answer. One last answer. Infrastructure as code, what is it? Okay, so let's take the next question. How do you define and use inputs within Terraform? All right, just put up your hand if you know the answer to that. How do you define and use inputs, values, and variables within Terraform? Anybody? Would you like me to take that again? If you'd like me to go back to that, just raise up your hand. Okay, so I have one vote. Someone says I should go back to show how you can define and use input variables within Terraform. Okay. So just taking a quick step back. You see here, okay. So here, rather, we have our variables.tf. We have our variables.tf here, where we set a region to EU West 1. If you know where EU West 1, what's country that is, drop it in the chat as well. So we set our region here to EU West 1. And in our provider, we call the region that we've created using var. So we use the var keyword. We do var dot region, and that specifies, that points to the region variable that we've created right here to be EU West 1. Right. So do we all understand? Do we get it now? Yes, EU West 1 is Ireland. Well done, John. Okay, so let's move on to the next question. What are modules in Terraform and why are they useful? What are they? Why do we use them? Anybody? What are modules? Why are they useful? What are modules in Terraform? Okay. Michael has his hand up. Is there any other person? Okay, Michael, go ahead.
Sorry, am I to use my own understanding or should I just shoot a shot as you explain? Let me first start with that one. Hello?
Hello. Yes, from your understanding.
Okay, so modules are actually IACs that when being deployed and be usable inside the Terraform in the infrastructure that you are working with. So we have a situation where once you deploy a module initially, you can actually get to reuse that same module in multiple places. So in a code like understanding, just like a function that can be reused.
That's thank you for that, Michael. Adedeji, what do you think a module is and why is it useful?
Well,
Or maybe you can explain. Okay, go ahead. Try to explain why they are useful too.
Why they are useful?
Yeah.
To avoid repetition in our code, to make it dry, not to repeat ourselves.
Yeah.
Yeah.
That's excellent. Thank you for that.
All right.
So to the question of logic now, how do you use conditionals in Terraform? And how do you use counts? And let me go back to that counts one. So again, the for each, it's like your for loop when you're doing a for loop, and your count is like when you're doing your while loop in Terraform. While these conditional statements, you just think of them as when you're coding and you're using if else, right? So that makes it just faster to understand. All right, so we are now at the end of the theoretical parts of our lecture. Let us now touch on some practical exercises. If you have any questions related to the lecture, yeah, you can go ahead.
All right, sir. Thank you, sir. So the HCL, is there anything specific to learn about it, or it's just straightforward?
That's it, the what? HCL.
HCL, yes. Are we supposed to learn it? Is there anything new to learn about it, or it's just straightforward?
HCL is what you'll be using in Terraform. It's just like the underlying language that Terraform uses. So
And
specifically be learning Terraform, not exactly the HCL language. There are various tools that HashiCorp created. So using the HCL language, you can interact with those tools. Like you have Vault, you have Console, you have Packer. So using HCL, you can work with many of those tools. But specifically today, we'll be working on Terraform. All right, so we are back again in our AWS console. Today we'll be working on creating an EC2 instance using Terraform, right? So I would open EC2 here. I will see presently I have no EC2 created. No instances running within my EC2 environment. So I'm going to I think I have a question from Michael.
Yeah, I want to ask. So when one creates an EC2, is it still going to be, is AWS still going to charge you for that?
Is AWS going to what?
Charge you for creating an EC2 without running it as an instance?
If you create an institute with Terraform, are you going to be charged by AWS? Is that your question?
Not with Terraform, but even without Terraform.
Yes. Create an institute instance, you'll be charged for it. For the amount of for how long to keep it running.
Not running it as an instance, so I'm asking it to just create it without running it.
Create institute and it's not running. Is that what you're talking about?
Yes, sir.
You create an institute and it's not running. Would you be charged for it?
Yes,
So
that's my question.
It's created it's attached to a volume, which is EBS, where your data is stored. That will be your disk. So even when you might not be charged for your EC2 because it has been stopped, you might still be charged for other things connected to EC2, like the volume. If your EBS volume is collected, it still has data in it. You still have your EBS created. You'll be charged for EBS. You can, if you also have an IP address attached to your, maybe an elastic IP attached to your EC2 server, and you don't release that IP, you'll be charged for that elastic IP as well. Right?
Okay.
Okay.
Thank you for telling me that one.
You're welcome. Okay. So I think we are ready. Just in a moment, I'm trying to set up the environment we'll work with. I hope you can all see my screen now. Try to make this as big as possible so that everybody can see it. I'm bringing up my terminal. My terminal now. And in here, I'm going to create, watch me. I'm going to create those three major files that we spoke about. So I'm going to create my main.tf. I'm going to create my variables.tf, and I'm going to create my output.tf. All right. Now it has created these three files for me. And working with Terraform, the first thing I'm going to do is to specify my provider. Right. By the region as EU West 1. For that, I can initiate this directory as a Terraform. Initiate this file, this main file, my Terraform main file. I put Terraform in there, and I'll put in some required providers. AWS, right? It's also important to something missing here. Version. I think I'm supposed to put in the version here. Okay. Thanks. I'm not sure the particular version that's in use now, so I'll just check that out in the provider. So your phone provider. Okay, so you're using 5.570, right? So you can still come to my required providers. It's AWS. And I can put in the source and the version now, right? Okay. Okay, so this has given me the version of AWS that I'm going to be using. The version of HashiCorp's AWS. That's the version of the provider. And then I specify some configurations to the provider itself. And then next, I'm going to create a resource, right? I'm going to create a resource. I'm going to create an AWS instance, right? Then I would name it, maybe I'll just name it AWS instance this. Right? So, what else does it need? It would also need, by default, this will just create it within the default VPC, but I can also work on creating a VPC where to deploy it. So the var.ami with there. The name, I want to give it a name. Okay, what's the name? I'll come to look for AWS AMI IDs, right? AWS, let's see Ubuntu. That is 22. The lists will be somewhere on this page. Okay. We're just coming to AWS right here. Search for Ubuntu. We take this ID, right? Then we come to our variables file. We are creating a variable AMI. Let's name that AMI ID, rather. And we are setting, we put a description saying Ubuntu 22 AMI ID. Right? And the default, we're going to set that to this value. Now, coming here. Yeah, my ID, like we want it. And another important thing that is needed for EC2 will be the instance type. It's the instance type, and we'll obviously, because we want to work with our variables, so these variables can now be reused as many times as possible too. So it's also a way to make our code reusable. So come to our variables and create another variable here. And we say, oh no, that will not be a good name. There's already a key here. So let's name it EC2 type. And that's EC2 type. And I'll just set the default to c2.micro. Right. Let me do some tagging. When I come to tags here, description, into tags, so right, and then I'm going to set the type here to map to a map of strings, then the value false would now be, I'll set the name to maybe web server, set the environment to probably development. I'll set so there are different types of variables you can use. I'll show let me see. Development, and then I'm setting the anything else, the projects to be KC KodeCamp, right? I can also so when we come to variables, let's see example variable now, right? And come to type, you can see there are various types that you can set your variable to. You can set it to a bool, which will be either true or false. You can set it to a list. You can set it to a number. You can make a set. You can make an. So there are various types of objects there are various data types that you can assign to your variable. Okay, let me quickly take a question. Michael, you have your hand up. Please go ahead, so that I won't go too far.
I was actually trying to figure out how you're able to, where you called, how you make the variables global so that it can actually be accessed in the main and the output, because I was not even seeing any connection from the variable.ts to the rest of the
It
file.
cannot be accessed to
Other files, because you share the variables in the variable.ts file. How are you able to access make them accessible in the two files?
Okay, that's
actually
Terraform in the main file is actually looking for a file called variables.tf. Like it was created created that way to look for variables.tf as where variables will be inputs, right? It also is looking for a file for tf vars, right? If I create right, I can now use this file to have all these default values, but I just decide to put the default values within the Terraform file itself, right? Because that's just how I work. So it's actually looking for this file, the TFVARS file, and it works with that. The variables TF file actually. Okay.
So what you're saying is these three main files that you share is actually what Terraform demands, and it's consistent in all other. If you want to create a Terraform file, that's what you're saying. You cannot change the name. Okay.
You can add some other files with different names, but you shouldn't change the names here. You should name it main.tf, variable.tf. You should in your Terraform directory, you should have a main.tf, you should have an output.tf, and you should have a variables.tf. You should have a main.tf and a variables.tf specifically. I can also create an ec2.tf, right? And take all of these resources that I'm creating here and put it in there and have my ec2 created separately, right? But this main.tf has my Terraform configuration with the required providers and the version of the providers and the source of the providers that it's using. Also, it can have the provider resource, can also have my backend. Can also have my backend that I can create here. But right now, I'm just going to leave it as to create the local state file, right? I hope that helped. Okay, go ahead. Another question.
So, continuing, I just noticed that there are also a bunch of properties that have been attached to, for instance, required folders, providers. Is there a form of?
And I'll just explain that as we go ahead. I think I've touched on that before actually, while I was writing it. But we can come back to that. Let's just try and create this resource.
Let's continue the question.
All right. Thank you, Michael.
Sorry, should I continue the question? Because I just wanted to.
So we have the variables here created, and we also have our instance created as well. We are now going to deploy this. We're going to deploy this instance that we've created. And then we can come back to see whether we can refactor this code to include looping and some other logic. So the first thing we are going to do is to do the Terraform init in this folder, right? We are in our Terraform folder, and we want to do the Terraform init. We have all this. We have these basic standard files that we've created: the main.tf, output.tf, and the variables.tf. Okay, let's create an output. We want an output here. Perhaps we name its instance ID. Instance ID, and that should be value will be, and the value will specify it by specifying the resource name, AWS instance, and this name here, dots ID. So let's do that. We have AWS instance dot this, the name we gave to the instance, and our ID. Right. So that will output this here, and we can now use that in another file. Okay, so let me Terraform init this so we can all see this. Terraform init, and it's initializing our backend. Installing our provider. Okay, while that is installing, let's take a few questions. All right, go ahead, Michael.
I just wanted to ask if there is maybe a documentation that states what kind of properties that we use to fill in those, for instance, providers and the resource that we can check just in case for reference purposes.
Okay, I think I can share the AWS document, the Terraform documentation. It will provide you with the various resources that you can use. Let me share this my screen. So this, when you come to this link, providers, or you can just search for, like what I did, I just searched for AWS Terraform provider, right? And the first link that they gave to me is the AWS provider HashiCorp. They also gave me the GitHub link, which you can also look at. So from here, you see that it gives you the provider. So it shows you the version you should use. What I can do, okay, I've already installed it, but a good practice would be to not specify, well, you can specify a particular version, or you can specify something like this, where it to be anything greater than any version greater than 5, right? Can also work like that, or you can just specify the direct version you want. So this shows you can pick the version from here and do some configuration to the provider. And in here, you can now see the various resources available to you. See the various resources available to you. You have basically every AWS resources here. You have EBS, you have EC2, you have EC2 image builder, You have data pipeline. Oh, data pipeline, I thought it had been discontinued. You have your cost and usage reports. You have EFS, you have ECS, you have ECR, you have EKS. What else have we talked about? I think S3. You have IAM here. See, you have IAM. Where is S3? You also have Route 53, you have S3. So every resource you will need, where's VPC? You have VPC here as well. So every resource you need, you can get it in here. Okay, let's see VPC. All right, let's look at this VPC. Some resources under VPC, you have AWS default VPC. Now this AWS default VPC here is what I'll put here as resource. If I'm creating a VPC resource, I can do resource AWS default VPC and set the name to what I want and some of the attributes. So okay. In the name, we specify the name. Can also specify the setup block and instance tenancy argument become computed attributes. Yeah, you can also create a subnet using this, and in this the attributes that's it takes are the availability on the setup block and the VPC ID, right? This one takes the setup block and the instance tenancy. So you can just work with any of these resources here. There's AWS VPC here. Okay, this is to create an AWS VPC. This right here, AWS default VPC, is when you want to work with on something on the default VPC that AWS creates for you, right? So this is actually AWS VPC. To create a VPC where you can specify your setup block. And these are some of the attributes at stake: setup block, IPAM pool, and all of this. So this documentation can just show you what you need to create and all of that. There's also the one for Azure. If you come to providers, you have providers, say Azure, for instance, and in Azure, come to the Azure documentation, you also have, where is VNets? You can, okay, you have network here. And you can also do some of these creations within Azure. Michael, do you understand?
Loud and clear.
All right, so that's it on documentation. Let's go back to AWS. Of course, you have Kubernetes, you have Google Cloud Provider as well. So we are in AWS. Okay, so we have done the Terraform init and see what it did for us. Initialize the backend for us, which will be the default backend because we did not specify a backend. It's also installed the providers, and then Terraform has been successfully initialized. And what it has done now, as you can see here, it has created a hidden folder for the Terraform for us and installed the provider in there with a license. It has also installed a log file for us. Oh, someone else had a question, and we'll take that in a bit. Okay, so I'm going to do Terraform plan now. Remember, we had 4 commands. We had the Terraform init, we had the Terraform plan, we had the Terraform apply, and we also had the Terraform destroy. So let me quickly do the Terraform plan so that I can see what changes it's going to make within my, oh my goodness, sorry about that. Terraform plan. Now I can wait for it. So it has shown me here that what is it going to do? So Terraform will perform the following actions. It's going to add a resource AWS instance VPC. With the AMI, it uses AMI, the ARN known after apply. What does this mean? Known after apply means that after it creates this AWS, that's when it should attach the ARN there, all these things here. So if I want to get them, maybe I want to get them and use them in another module or something, I can go to my outputs now and I can do something like outputs, right? Instance ARN. So that's when it runs this, it gives me the value of the ARN. That's when it runs, it gives me the value of the ARN, right? But I don't want to do that. So let me take that out. I have the ID. See the ID right here. It's also saying known after apply. So after you apply it, that's when to show you the ID. Also, it's good to know that you should also make sure you have the right AWS profile that you're using to write AWS profile. Right now, I'm using my default AWS profile, which is this account. If you have different configurations for AWS within your environment with different profile names, try to specify the profile name using the dash file. Okay, so I'm going to apply this now. Yes, so okay, so it's wrote something here for me. It says you didn't use the dash out options to save this plan. So Terraform can guarantee to take exactly these actions if you run Terraform apply now. Right. So I can output this values into a file and apply that file. If I do Terraform plan dash out and do EC2 plan. If I output that, where is EC2 plan? So it has created this text file for me here called EC2 plan. Let me delete that. I'm going to do this again. I'm going to give the plan.txt because it was saying that the extension or the file type wasn't supported. So I'm going to do .txt and I'm going to, so it has created this plan.txt. This file is not displayed in text editor because it's either binary. Okay. So it's encoded, or it's a binary file, so you can't view that. So that is a way to save the plan, and then you can now apply that particular plan and maybe go on with other things. But I'm just going to apply it straight. I'm going to apply it straight using my Terraform plan, apply. So I'm running Terraform apply. Now, this will apply these changes here, because I've not made any additional change. So I didn't save it. So it's going to apply this. It's going to apply these changes that are right here in the plan. Okay, so Terraform apply, and I do the enter. Do you want to perform these actions? So I'm going to put yes. Let me see the VPC that it's creating this in. Does it show me that in my get password false? Yes, optimized. Private IP. So, subnet ID. I would like to know the VPC. Maybe this is subnet group ID. I'd like to know the VPC that is creating this thing. But basically, it's obviously going to create this in the default VPC. So I've put yes, and I'm applying this now, and you can see that AWS instance is creating. You can see the Terraform TF state here. Oh, hold on. It's going to populate that after. So it's creating it now. It's creating that instance, and we are just going to wait for it and maybe take a few questions or comments. Yeah. So it's still creating the instance. I don't know why it's taking so long. Okay, so we see here that it has shown apply complete, right? And it has given us an output, which is the instance ID. Why? Because we specified the output here and told you that it should give us this output. And then we see the instance ID, whatever this is. And so we have the ID here. If we come into the state file, we can see the states right here. Right? So we see the state file that's created for us. This state file, you know, if you're working with a distributed environment, it should probably be remote. It shows us all the configurations of this resource saved here. Try not to mess with this or make any changes here so that you'll not have problems. Right. So let's go into AWS now. Come into AWS and we come to instances. We can see that this instance, are we in the right? Where did it create this? Okay. So it looks like I've created this within the wrong AWS accounts. Okay, let me take a few questions. This was created in wrong AWS accounts. Okay, Michael, please go ahead with your question while I try to sort this out.
Okay, so out of curiosity, I was actually trying to figure out where you were able to integrate, like connect the Terraform files to your AWS account. I was not even able to track that. To connect the Terraform files or project I just did to your AWS account, I wasn't able to track it.
Okay.
So I was actually
Okay. Yeah, just give me a moment. Let me.
okay.
Okay. So Michael's question is a very important question because that is exactly what's happening here now, right? So we have my environment right now has a number of AWS profiles on it, right? When you do the AWS configure, right? If you have AWS CLI installed and you want to work with the CLI, so if you do AWS configure, you get to configure you can now specify your accounts to use the AWS CLI. So when you execute a CLI, you can execute it on the particular AWS environment that you want to work with. This gives, when you do AWS configure, it brings out it will ask you for things like your AWS secrets ID and your AWS secret key. And that's what you use to create or interact with your AWS environment using your CLI. So I can perform actions like AWS S3 lists, right? Okay, AWS S3 LS, and to list out the different these are the different buckets within my environment, right? Okay, so if I come to my S3, see what's in my S3. Okay, so you see this S3 now. This is the S3 of my buckets, and there's only one bucket here, right? But when I did AWS S3 LS here, you see that they have a number of buckets here. So obviously this is pointing to a different AWS account altogether. So what I'm going to do is to try to log into that account so that you can see what it has created there, right? So just give me a moment. I would rather do, because this is a teachable moment, I would rather do a Terraform destroy here to destroy this thing that has been created on that environment, right? So I'm doing Terraform. Can we all see hear me? Michael, I hope you're following. So I'm going to do a Terraform destroy.
I don't think, boss.
Yeah. So I'm going to do a Terraform destroy, and it's going to destroy that instance, right? Yes. So it has already, it will show you what is going to happen with this command that is going to take out all of this, delete this AWS resource. And I'm going to do yes, right? Okay. So for the sake of this class, I am going to do something within my AWS account here. I'm going to come to, and this is for people that want to work with or do a walkthrough. So I'm going to come to my IAM. All right. You can come here to security credentials, but I'm going to come to my IAM. When I come to IAM, I'm going to go to my user. Remember, I have admin privileges, right? So I can do this. So I'm going to come to my user. There are two users here. I don't know why. Okay, I left the KC user. This KC user, what permission does he have? He has Amazon EC2 full access, Amazon RDS. Okay, so I'm going to this KC user now, for instance, since he has the Amazon full access, he can create, he has the EC2 full access here, can create EC2 resources. Let's try to follow the class for now. So when I come to this user, I'm going to come to security credentials here. Then I'll come to access keys, right? So I'm going to create an access key, and you see what it says here, use access keys to send programmatic calls to AWS from AWS CLI, AWS tools for PowerShell, AWS SDKs, or direct AWS API calls. So Terraform works with AWS API calls as a provider, as specified provider. It uses API calls to work with all these AWS resources. And you can create a maximum of 2 access keys. I'm going to create an access key now. Access key best practices. What do you want to use it for? I want to use the use cases for the CLI. You plan to use this key to enable AWS CLI. So some recommendations. Alternatively, you can use the AWS Cloud Shell, or you can use AWS. So why it's giving you these recommendations is because it's not very recommended to use access keys, especially when working in a production environment. Why? Because they are long-lived keys, right? So since they are long-lived, if anybody has access, gets a hold of that your key, they will have access to your environment through that user. And all the permissions that user has, they will have those permissions through that key. So there are other ways of doing authentications. You can use ODIC for authentications. You can use SSO, that is single sign-on, using for authentication as well. And this gives you the ability to make use of short-lived keys that are just provided to you when you want to use them. But for the sake of this class, I'm going to create an access key here. I understand the above recommendation, and I want to proceed with creating an access key. So I'm going to go to next. I'm going to the description, programmatic access through AWS CLI and Terraform, right? So I'm so happy this error happened so that I can come to this aspect of the class. So now it's going to show me my access key and my secret key. And this will be the only time to show me this, right? So if I lose this access key and this secret key, I'll never have access to this access key again. It's part of the security practices and policies of this. So never store your access key in plain text. Disable and delete key when no longer in use. Enable least privilege permissions and rotate key regularly. That means delete and add a new key. So I'm going to download the CSV file, which will contain the access key and the secret key here. I'm going to download that. So it has downloaded that, and I'm going to click on done. Then I now see that let's just reload this. I now see that there's an access key attached to this particular KC user, right? So what am I going to do? I'm going to come into my terminal here. I'm going to clear this. I'm going to list out what I have in my downloads. And I'm going to do grep so that shows me what did I KC user. So I see that I have a KC user access key here. Let me see which one is the latest one. Okay, so 9th of July. This one, if I cut that out, if I cut that out, I'm going to see the access key here and the secret key. So I'm going to do my AWS configure, set profile name. I think this is how to set profile name. Let me see help. I want to find how I can set the profile name. So it's giving me some information about this. Let's list profile. Okay. So I can do the AWS configure dash profile and give it a profile name. So I'm going to do just that. Let me do AWS configure dash profile. I set the profile name to KC user, and it's going to ask me for the access key ID. I'm going to copy this access key and paste it here. Next is going to ask me for the secret key. I'll copy this one, paste it here. Then it's going to ask me for the region, default region. I can decide to put it, it's optional. I can decide to put it, so I'm going to set this to away. I'm going to set this to EU West 1. And default output format, I'm not going to set that. Then I'm going to enter, right? So let me come to my Terraform profile here. If I come to my documents, I go to KodeCamp, obviously. I'm coming to hands-on. Then I'm coming to, is it Terraform I named it? Yes. So I'm in Terraform now. Listed. I have all of this, right? I have the variables, the backup, the state file, and everything. Now I'm going to do Terraform plan profile. AC user. It doesn't know that. Let me see Terraform plan help. Perhaps to show me a way to specify the credentials. Get config out if input blocks open. No, not that. Question. Who has a question, please? Please go ahead.
Okay, good evening, boss. So I was just thinking if there's a way we could easily specify on VS Code 2, like just add the credentials on our access key and
There should be.
I think that would be.
Find out. I'd be able to do that through the use of one of these extensions. Just a quick research session now. Let me find out how to do that. To specify the particular okay, should be in your provider. Okay, so quick research has shown me that it should be in your provider. So this provider here, you can specify the profile name, the profile, and put the profile name that we have as KC user right here. So when it's looking in it for your AWS credentials, it will check for this name, right? That's the name we gave it. Let me look at my terminal one more. Oh, sorry. Okay, so this is what I was saying. You specify it in your provider block here. So the configuration should pass to your provider. I'm specifying the profile, which, so it says the profile optional string is optional. The profile for API operations, if not set, the default profile created in AWS configuration will be used. So obviously it's used the default profile that I had, which put it on my another account altogether. So this now will put it on the account that I put as KC user. I'm coming back into my terminal here. Let me just confirm that it was KC user I created. So yeah, KC user was the profile. Yeah, the profile KC user. So I'm going to try and run my Terraform plan again. And wow. So I will do the Terraform inits. Terraform inits again because it has initialized this Terraform directory using that. It has initialized this Terraform directory using that default profile name. So I'm going to do the Terraform init upgrade so that it can update, or is it update? So that it can update the initialization files that we have. Okay, so let me see. Configure the backend, this, that, updates, upgrade, sorry, install the latest module, override the default behavior of selecting exact data version recorded in independent log file. So I'm going to do the updates rather than, I wrote upgrade before, so let me change that to upgrade. And so initializing backend, this is the same thing we're doing. Sorry. This is the same thing so that I don't get confused. This is the same thing we're just doing in this terminal here, right? So I'm just doing it in my terminal instead of doing it in VS Code. So this has reinitialized my backend, initialize provider plugins, finding Dashcop, using Dashcop installed. So I initialize the provider and the backend, and I'm going to do Terraform plan again. Plan. I hope we'll get to touch on modules today. So it's doing the plan. It has done the plan. These are the things that will be added. So now it's doing, let's do the Terraform apply, right? Do you want to apply? Yes. So to create the EC2, now it's creating this, and let's take some questions, please. Some people are not understanding what I'm doing. Michael, go ahead, please.
I wanted to actually do a little bit of walkthrough, so how you're able to connect your AWS
How many
this
people
thing,
connect AWS?
AWS Terraform. So what exactly you did was you're able to use you created an account, user account with use of AMI, and then the only
I
part
am.
I say I am. I think
Yeah.
AMI. Yeah. So then you are able to access AWS console with either account in your terminal locally in your SSH, a true use of SSH, correct?
Okay, let me go over it again. It wasn't SSH at all.
Okay.
So this user, I am. I created a user. Remember in our last class, I created this user, KC 4 days ago in our last class. I created this user called KC user, right? This user, I gave him access to EC2, gave him access to S3, RDS, and the access to change his password, right? So this user now, I just came into security credentials and gave him an access key. Basically, just assign an access key to him so that he can access AWS using CLI, using SDK tools and make ACI calls with this access key. Now, this access key, I now did, because I have AWS CLI installed on my system, right? Okay. So if I come to my system, I do AWS CLI version, yeah? Let me do AWS version. I have AWS CLI downloaded on my system and installed, believe it or not. Okay, let me try this dash version. Okay, yeah. So AWS dash version, you see that I have AWS CLI installed here. You can simply go on the internet and find out how to download and install AWS CLI. So I have that installed. So I'm able to do AWS configure. I'm able to execute this AWS configure command, right? And with this command, I did AWS configure. I now set the profile to KC user. So this creates a user for me called KC user. And this will be located where? To create this configuration file and save the credentials for that user, which I'll specify because it downloaded the access key and the access key secrets. So it will specify, it will save this in a location in my folder, in a directory in my computer called .aws, a hidden file called .aws in my home directory, right? So if I come to my home directory, right, if I list my home directory, I see these files here. If I do ls -a to list out even the hidden files, you can see this one right here. .aws, a hidden file, a hidden folder, .aws. If I list out what's in there, right? It's AWS. Questions will make me explain a lot of things because then I know that the part that you're not understanding. So try to ask questions frequently. No question is stupid. So if I list .aws, right? You see that I have config and credentials. If I open these credentials, God forbid, you'll see the credentials of the AWS accounts that I have on the system, right? But I won't open it because I have a lot of secrets there that I don't want anyone to see. Just like you wouldn't want me to see your own secrets. So what I did for this AWS configure, created the credentials and saved them in this folder, in this file, sorry. So when I do, I now added that profile name, right? So you have various profile names. You have the default profile, and then you now have various other profile names. So I now took that profile name that I created, I put it into my configuration for my provider right here. So when I run Terraform now, it knows that it should look for this profile, KC user, and use its credentials to create whatever I'm telling it to apply. If I come to EC2 here now, see. So we have one instance created, this instance, and if we come to the tags, if we come to tags here, we see the tags that we set: project, bootcamp, development, web server. So yeah, this is the instance that we just created right here in AWS. Because we were able to now specify this particular account. Do you understand? I would like a follow-up question.
Yeah, it actually makes sense. So I think the walkthrough is actually quite clear. The next question I wanted to ask is not directly for this, but it's for the task that was given. So I might just get to ask that now. Because it's still around the host. The next question I wanted to ask is not directly for this Terraform. It's for actually the task that you actually did previously. But
The
it's
previous
still
class.
tracking. Yeah, no, the task,
It's
the
not
use of
related to
task.
what you're doing.
Yeah,
It's related to what
it's
the
still
task.
bouncing around.
Hold on.
Yeah,
It's related to what the task.
yes, but
No, let's keep
it's
that to
like,
after the class. Let's keep that to after the class.
no, I know, but then it's still around the use of shell because I was having some
Michael,
issues trying
Michael,
to, yeah,
let's try to keep it after the class. Let's just focus on this particular lesson.
yeah. Okay.
All right, thank you. So I need more questions about what we just did here. If it's not clear. Should I go ahead and destroy it? Okay, ADDG.
Hold on, sir.
Hello, good evening. How are you doing?
I'm fine, sir.
All right.
I'm just curious if we can do this with Cloud Shell. Is it possible?
It's Cloud Shell.
Yes.
Hmm. How would you like to do it with Cloud Shell?
I don't know, that's what I'm
Cloud
asking.
Shell
If
now. Cloud Shell, if we come to Cloud Shell. Yes. Yes, definitely. Because Cloud Shell, I think they now provide there's a text editor there for you where you can write code. Am I correct?
yes, sir.
Yeah, so you can do it in Cloud Shell too. Because Cloud Shell would even have a direct access, right? Configuration to the AWS account it was created in. Am I correct about if I remember it correctly? If you create Cloud Shell, that Cloud Shell will have access to various services within AWS. I don't know how much privilege it will have, but yeah, I think it will have that. So you can do this in Cloud Shell. Should you do it in Cloud Shell? How would you have how will you have the code? How will you work with version control if you're doing everything in Cloud Shell? You just consider, look at your use case, look at what you're trying to do, and just know the best way to go. Yeah.
All right, sir. Thank you, sir.
Thank you. You're welcome. I have another hand up. Chica.
Hello, good evening, sir.
Hello, good evening, Chica.
My question is the stress of this Terraform when we can do everything on AWS.
Okay. So look at a situation where you're employed into an organization and they tell you that, okay, this organization has an EC2 server setup, and this setup was done by the engineer whose shoe you're feeling, right? He has left the organization. And then you ask the person that is employing you, okay, what was configured on this EC2? And he tells you, I don't know. It's the other engineer that did it. You have to reach out to him to know what he implemented on this, because he just went into his console. You were not there when he did it. He clicked some things in this AWS console and came up with this server, deployed this server. So if you want to know anything that he did, you either have to come and start assuming or come and start clicking around here to know how the configurations and how everything works. Or you have to go and ask him what he did. Maybe he did it 5 years ago. I'll tell you, I can't really remember, or something like that, right? Just suppose that with a situation where you have the configurations all written down and saved on GitHub, right? So that configuration can now be deployed, right? And you that you're just coming newly into the team, you can also go there and read the configuration files and see what was deployed, how it was configured, and everything. You can also easily set up many instances at the same time. Imagine you want to set up 60 instances with the same configuration. Do you want to come and start clicking one by one for 60 of them? No. You would like a way to automate the creation. That's what Terraform can help you do. That's what infrastructure as code can help you do. Infrastructure as code can also help you to version your code. So you can see, if you have version control on your IAC, you can see the changes that were made to your infrastructure 2 weeks ago. You can see what was running on your infrastructure 2 weeks ago, and you can see what's running now, right? You can go back in history. You can roll back to previous states, previous configurations with IAC. What you have to do if you're working with the AWS terminal directly, AWS, what was this, console directory, directly, you have to try to remember what was set up before, right? So it helps you with version control. It helps you with history, keeping history. It helps you with automated deployments at scale. If you want to deploy a large number of resources at the same time, it helps you with configuration management as well. So those are just a few of the advantages that you can get with infrastructure as a code.
Thank you. I understand that it helps with documentation, automation, and version control. Is Terraform the only format for that offers automation to AWS services?
Okay, so with infrastructure as code, you have various tools that you can use. You can use Terraform, you can use Pulumi, you can use Salt, you can use Puppet, you can use okay, yes. I don't want to say Ansible
Which
because
one of
Ansible is something else.
okay to learn?
Sorry, I didn't get that.
One of them, the Salt, the Puppet, Terraform. Which one of them all you listed is the easiest to learn,
All of
to
them,
understand?
and at the same time, none of them, depending on how you're looking at it. You can't really say one is easy. It depends on what you want to do. So these tools depend on what you're trying to do. They depend on how you plan to do what you want to do, and they depend on your use case. So looking at Terraform and Pulumi, for instance, right? Terraform works with the language HCL, just a specific difference, right? Terraform works with the language HCL, so you have to learn how to write configurations with HCL, right? But if you're working with something like Pulumi allows you to use whatever language you're working with. Like, I think it comes in the form of a library, and you can use Pulumi with whichever language that you're working on to write its own configuration script. So if you know Python, you can just pick up Pulumi as a library, right, and start working with Pulumi using Python programming language. You can use JavaScript with Pulumi as well. You can use whatever to specialize a specific difference. So you can see here, right? I'm on their web page now. You can see with TypeScript, you can import it as a library here in Python, and you can use that to create various resources with Pulumi. Meanwhile, Terraform, you can you use that. You have to learn the HCL language. Now, what is easier depends on you. It also depends on what the team you're working with is using. It also depends on how you want to implement this, right? So it just depends on what you want to do. I can't really say one is easier than the other because that will not be an accurate thing to say. So none of them is easier than the other. None of them is harder than the other. Depends on what you want to do, how you want to do it. Right.
I have another question. It's controversial, but it's strictly on this topic. So the question I want to ask now, I want to ask you, just like um as someone that is teaching us, impacting knowledge, do you know all of them? Do you know how to use all of them?
No, I don't.
Okay,
But
let me put it like this. Do we need to learn all of them?
when it comes to
Because you're making me understand that each of them is unique, depending on what is needed. So if I stretch myself to learn this Terraform, and an organization will now tell me to go and learn Follow Me. Other one will go and tell me to learn. I just want to understand.
okay, so
Those
let me tell you how it works. When you're talking about tech, or you're talking about software engineering, that includes everything from DevOps to UI UX, right? What really matters and what will really take you through the learning and execution and through the career is your understanding of concepts, right? So today I didn't teach you Terraform. I taught you infrastructure as code, right? And the tool I used to teach you that is Terraform. Okay. So if you understand the concept of infrastructure as code, there are various tools that help you to implement infrastructure as code. One of them happens to be Terraform. Okay. So if you learn Terraform and you understand the concept of infrastructure as code through Terraform, and you get thrown into a team that uses Pulumi, what you do, you can maybe take a month or so, I'm being generous, to learn the tool Pulumi. But as for the concept, you understand it. So, for instance, imagine I started this bootcamp by teaching you infrastructure as code. When I've not even shown you the AWS environment, I've not shown you anything about cloud engineering, right? You would find it more difficult to understand what I'm talking about. But in our last class, we spoke about cloud engineering. So now you understand the concept of cloud engineering. On top of that concept of cloud engineering, I'm applying the concept of infrastructure as code, right? So the concept is what you're learning, and the tool is Terraform. As you've learned cloud engineering now, you know about that if you want to set up an infrastructure, you need some form of compute, some form of server. You also need some form of volume for storage of data in the form of maybe EBS. Maybe you need a database as well to store maybe customer data and all of that. If I take you out of AWS and take you into an Azure environment now, you ask me, okay, I know about EC2 in AWS. What will I use to set up servers here in Azure? And they tell you, oh, you use Azure virtual machines, for instance. Then you just apply the knowledge that you took from cloud engineering in AWS into your Azure environment, right? So to become a DevOps engineer, you shouldn't learn, you don't need to learn all of the tools. You need to learn the concepts. And that's what we are doing here in KodeCamp.
okay.
All right.
Thank you.
All right, thank you. So I'm going to destroy what I've done now. Am I in the right place? Yes, I think so. So I'm going to do Terraform destroy to ask me if I really want to destroy it, and I'm going to say that yes, I really want to destroy it. So it's destroying the instance right now. Let me see if there are any questions in my comment section. Okay, so no questions there. Okay, so it's still destroying this instance. And I'm waiting for that. So you see this right here, right? It created an EBS storage for my and attach it to my EC2. Right. So if I stop my EC2 instance, like Michael asked earlier in the class, this EBS storage is still there and it's still holding data for you. So you'll still be paying for this. So just something to know. This might take a while. Let me check here to see if it's still running. Okay, so if you can see my screen, you see that it has stopped the instance. We have no instance running here, although it's still showing that it's deleting. So that is it for infrastructure as code. Let's keep practicing. Try our hands with creating creating a VPC, creating other forms of resources, maybe an S3 bucket. We will all try to create an S3 bucket. In our next class, we will just do a proper hands-on, where we'll see how we can interact with modules, how we can interact with logic. We didn't have the time to go into all that today, but we'll do that in our next class. So thank you, everyone. Thank you so much for joining. And let's try to keep up. It's an interesting infrastructure is interesting. Working in infrastructure is interesting. I'll tell you that you get to see a lot of the parts of a product from a low level view, and it's a very interesting position to be in. So let's try and learn the concepts, learn the tools, and be encouraged to do our own research, our own personal projects, and keep improving ourselves. Thank you so much. Please join us again in the next class, and till then, have a great